Hi, this is Kumaraven, Assistant Professor ECE from RMD Engineering College. Today's topic we are going to discuss about JK flip-flop. Okay, JK flip-flop consists of four NAND gates. Among these, two NAND gates are three-input NAND gates and two NAND gates are two-input NAND gate. In case of three-input NAND gate, one of your input is clock pulse, other inputs are J and K, and third input is nothing but your feedback. Similarly, if you consider NAND gate 3 and NAND gate 4, your NAND gate 3 input is nothing but your NAND gate 1 output. Similarly, one of your input of NAND gate 4 is nothing but NAND gate 2 output. The other inputs are feedback from your output. Okay. Now let us see. In case of NAND gate, we know very well that what if any one of your input is 0, your output will be 1. If all your inputs are 1, your output will be 0. This is what we need to remember. In either it is a 3 input NAND gates or 2 input NAND gate, if any one of your input is 0, your output is 1. If all your inputs are 1, your output will be 0. Okay. So now let us consider when clock pulse equal to 0. Okay, when clock pulse equal to 0, so now what happens? So we know that, right? If any one of your input is 0, your output of your NAND gate is 1. So when clock pulse is 0, your output of NAND gate 1 and NAND gate 2 is 1, irrespective of your J and K value. J and K could be either 0 0, 0 1, 1 0 or 1 1. Your output of NAND gate 1 and 2 are 1 and 1. Now let us consider Q equal to 0, then Q bar is complement to Q, therefore 1. So now this 1 is applied here, two inputs are 1, your output is 0. Okay, when now this 0 is applied here, if any one of your input is 0, your output become 1. So what happens? Your next state is nothing but your previous state itself. So when clock pulse equal to 0, what we have to understand is there is no change in state. Your previous state is nothing but your next state itself. Now we'll see the other case. Okay. So now when your clock pulse equal to 1. Okay. Now let us consider J equal to 0 and K equal to 0. Okay. So now what happens? So okay, when J equal to 0, K equal to 0, as we know that what if any one of your input is 0, your output become 1 in NAND gate 1 and NAND gate 2. So obviously when your NAND gate 1 and NAND gate 2 outputs are 1, then your overall output will be what? No change of state. Similarly, let us consider the other case. If K equal to 0 and Q equal to 1 and Q bar equal to 0, now what happens? This 1 is applied here. When your two inputs are 1, your output will be 0 itself. Now the 0 is applied here. If any one of your input is 0, your output is 1. So your present state and next state are same, 1 0 itself. Okay. So now even if a clock pulse equal to 1, when your input 0 when input J and K are 0 0, then your output will be no change of state. Let us see JK flip-flop truth table, right? So irrespective of your clock pulse, when J equal to 0, K equal to 0, your next state is nothing but what? Your present state itself. No change in state. Okay, this is what we need to understand from this. So now let us go back. Okay, when we'll see the other case. When clock pulse equal to 1, J equal to 0 and K equal to 1. Okay, so now what happens? So irrespective of your third input, your NAND gate 1 output will be 1 because one of your input is 0. But in case of NAND gate 2, two inputs are 1. Based on your third input, your output of NAND 2 will vary. Now let us consider Q equal to 1 and Q bar equal to 0. So now this 1 is applied here, okay, and 0 is applied here. So then NAND gate 1 output is 1 and NAND gate 2 output is 0. Okay, so now this 1 is applied here. Okay, if so now NAND gate 4 inputs are 0 and 1. So now your output changed to 1. Now this 1 is now applied here, so now this will change to what? This will change to uh, 0. Okay, so what happen is, so when j equal to 0, k equal to 1, your output will reset from 1 to 0. Okay, now let us consider other case. When clock pulse equal to 1, when j equal to 0, k equal to 1, your output is reset. That is, if it is 1 means it will reset to 0. If it is 0 means it remain itself. So it is 0. Now let us go back to other case. Okay, when clock pulse equal to 1, j equal to 1 and k equal to 0. So now what happens? So NAND gate 2 output will be 1 irrespective of the third input. Okay, but in case of NAND gate 1, so we need to see the what will be your feedback input. So now let us consider q equal to 0 and q bar equal to 1. So now this 1 is applied here. Your NAND gate 1 output is 0. Okay, so now what happens? Let us consider this 0. So this 0 comes here. When 0 comes here, okay, so now what happens? So 0 1 means output 1. Okay, so now this 1 is again feedback here. So when 0 1, your output is changed to 1. Again what happens? This 1 is applied here. Okay, this 1 is applied here. So now it has become 1 1. So 1 1 means your output is 0. So if you consider about q, so it will change from 0 to 1. So it will be set. Therefore, the third case, when clock pulse equal to 1, if your j and k inputs are 1 0, your output will be set, that is set to 1. Okay, now let us see the last case. Last case is when clock pulse equal to 1, j equal to 1 and k equal to 1. Let us consider q equal to 0 and q bar equal to 1. Okay, because here it is 1, here also 1. So now based on the third inputs of your NAND gate 1, NAND gate 2, your output of NAND gate 1, NAND gate 2 will vary. Okay, so now what happens? This 1 is applied here and this 0 is applied here. Your output of NAND gate 1 is 0. Okay, it is 0 and NAND gate 2 is 1. Okay, so now let us consider. So now the 0 is applied here. Okay, when zeros comes here, so 0 1, so 1. Okay, when this 1 goes here, so now what happens? 0 1, it will change to 1. Okay, so now this 1 comes back here, 1 and 1. Okay, so now it is changed to what? 0. So it is changed from 0 to 1. So now let us see, it is changed from 0 to 1. Now this new 1 and 0 is applied as an input. Okay, so now what happens? Clock pulse equal to 1, jk equal to 1 1. So from 0 it is changed to 1. So this is changed to 0. Now this is applied as an input here. So here 1, here 0. So what happens? NAND gate 2 is 1, NAND gate 1 is 0. Okay, so now this 1 come here, here it is 0. Okay, 1 1 0. Now what happens? 1, so 0. Okay, when this 1 comes here, oh sorry, I made a mistake. Okay, sorry. So let us consider this is 1, this is 0. Okay, clock pulse equal to 1, j equal to 1 and k equal to 1. Okay, so now this 1 is applied here and 0 is applied here. Okay, so now what happens? If any of your input is 0, your output is 1. If all your input is 1, output is 0. Okay, when this 1 comes here, so if any one of your input is 0, your output become 1. Okay, now this 1 is applied to your input, your output of q change to 0. So now what happens? It will toggle. So right, it will toggle. So that is nothing but what? It change from 0 to 1 and 1 to 0. So the last case, when clock pulse equal to 1 and your J and K are 1 and 1, then your output will toggle, right? So toggle in the sense, right? So if your previous state is 0, then next state will be 1. Okay, if previous state is 1, then next state is 0. This is what we need to remember, right? These four states. So when jk equal to 0 0, irrespective of your clock pulse, your output will be no change of state. When jk equal to 0 1, so when clock pulse equal to 1, then it will be reset. When jk equal to 1 0, clock pulse equal to 1, it will be set. When jk equal to 1 1, clock pulse equal to 1, it will toggle. Okay, so now let us see the present and next state table of jk flip-flop, right? So we know that what when your present state is 0 0, okay, so your next state is also 0 0. Okay, let us go back to the table, right? So your present state is okay, your present state is 0 and next state is 0, which is means what? No change of state. Okay, when present state is 0 and next state is also 0, then there is no change of state. So what does it means? Okay, actually sorry, it is not here, so let us consider when jk equal to 0 0, okay, your present state equal to next state. So if your present state is 0, next state is 0. If your present state is 1, your next state is 1. Okay, let us go back. jk equal to 0 1, it will reset to 0. So jk equal to 0 1, so 0 1, actually present state is 0 0 means it will remains in 0 itself. Similarly we considered your jk equal to 0 1, if your present state is 1, it will reset to 0. Now we'll see the next case. Next case we know very well, right? When jk equal to 1 0, right? So 1 0, it will set to 1. So jk equal to 1 0, if it is 0, percentage is 0, then it will set to 1. So same 1 0, your percentage itself 1, so it will remains 1 itself. The last case is what? jk equal to 1 1, it will toggle. That is, if percentage is 0 means your next state is 1. Okay. Similarly, if percentage is 1 means your next state is 0. Okay. Now if we draw K map for your next state, okay, so here we'll have 1 for input combination of 0 1 0. So 0 1 0 here, then 0 1 1 0 1 1 here, then 1 0 0, so 1 0 0 here, then 1 1 0 1 1 0 here. If we group this, we can write the characteristic equation as qn plus 1 equal to j qn bar plus k bar qn. Okay, so now let us see the excitation table. So excitation table we can write from previous tabulation. In previous tabulation, right? So let us see. When present state equal to 0 and next state equal to 0, what happens to j and k? So j is 0, but k is swapping between 0 and 1. Okay, so therefore we can write it as when your q equal to 0 and qn equal to 0, your j is 0, but k is don't care. Right, it could be either 0 or 1. Simply consider other case. Okay, other cases are present state equal to 0 0 and next state equal, sorry, present state is 0 and next state equal to 1. 0 1 case. 0 1 case, what happens? jk equal to j is 1 and k is don't care. Okay, so for 0 1, for 0 1 combination, what happen? Your j equal to 1 and k is don't care. Let us go back the other case. So other case is what? Your present state is 1 and next state is 0. Present state is 1 and next state is 0. Under this case, what happens? Your k remains same. K is 1, but j will vary 0 and 1. Therefore, we can write. So for third case, that is 1 0 for present state and next state, your k is don't care and sorry, j is don't care and k is 1. Okay, the last case. Last case is present state equal to 1 and next state equal to 1. So under this case, what happen? Your k is 0, but your j 0 and 1. Therefore, we can write it as, so for 1 1, j is don't care and k is 0. Okay. So now using this excitation table, we can draw the state diagram. Okay. So what happens? So let us look into it. Okay, when j equal to 0, what happens? Your present state equal to next state, that is 0 itself. When j equal to 0, it remains in same state 0 itself. Okay, but when j equal to 1, it will go from 0 to 1. So that is j equal to 1 go from 0 to 1. Similarly, we can see for k. For k, right, so k equal to 1, what happens? It will go from 1 to 0. Therefore k equal to 1, it will change its state from 1 to 0, but when k equal to 0, it remains in same state itself, that is 1 itself. Okay, then finally we can draw the waveform. So we know the all the four combinations, right? So when jk equal to 0 0, no change, 0 1 reset, 1 0 set, 1 1 toggle. So we know it, right? So here we'll have jk input waveform and we have the clock pulse. So here it is positive edge. Okay, so what happens when your j equal to 0 here? So 1 for 0 1, it will be what? Reset. Okay, so for positive edge, what happened? From 1, it is reset to 0. For negative pulse of your for your negative clock pulse, it remains in same state itself, no change. So now what happens? So here again the positive edge, what happens? Where it become 1 1. 1 1 means what happened? It should toggle. So from 0, it should toggle to 1. Then negative clock pulse, it remains in same state itself. So here again, what happened? 0 0. 0 0 mean no change, so it will remain. So this is how we have to draw the output waveform for q for the input combination of j, k and the clock pulse. Okay, thank you.